Here is the rewritten and translated English language script, compacted to approximately 50% of the original volume, with full content preserved. There are 40 billion Earth-sized planets sitting in the habitable zones of our galaxy. 40 billion places where liquid water could pool, where chemistry could become biology. 65 years of searching every target we can reach has produced a single result: zero. We are going to trace that zero through 76 years of investigation, from a lunch table at Los Alamos to a signal that screamed for 72 seconds and never came back, to the economists and physicists who think they know what is killing every civilization before it gets loud enough to hear. In March of 2020, after 21 years of continuous operation, SETI at home quietly shut down. The project had used millions of volunteer computers worldwide to sift through radio telescope data for signs of intelligent signals. Over 2 decades, those computers processed 12 billion candidate signals. Every single one turned out to be noise. Not one confirmed extraterrestrial transmission. 65 years of formal searching, starting with a single radio telescope in West Virginia in 1960, across dozens of countries, hundreds of millions of dollars in mostly private funding, because the United States government stopped paying for this work in 1993. The answer, as of early 2026, is still zero. This is not a failure of effort. Breakthrough. Listen alone scanned approximately 1 million nearby stars and accumulated more than 2 petabytes of data. The cosmic system on the Very Large Array observed over 950,000 unique fields in its first 11 months. The Murchison Wide Field Array surveyed 2,800 entire galaxies. Every search, every instrument, every frequency band returned the same result: nothing. Meanwhile, the numbers of places where life could exist keeps climbing. Astronomers have now confirmed more than 6,000 exoplanets. Statistical models built on Kepler Space Telescope data estimate roughly 40 billion Earth-sized planets in habitable zones across the Milky Way alone. The observable universe contains at least 2 trillion galaxies. 40 billion possible Earths in our galaxy. 0 signals detected. Statistical models built on 6 decades of null results constrain the number of detectable technological civilizations in the Milky Way to fewer than 1 to 5 per century. That is not a guess. That is what the data says. The question this investigation follows is simple to state and very hard to answer. If life starts easily and planets are everywhere, what is killing every civilization before it can reach us? Los Alamos National Laboratory, summer of 1950. 4 physicists are walking to lunch: Enrico Fermi, Edward Teller, Herbert York, and Emil Konopinski. The conversation is light. Someone mentions a New Yorker cartoon about flying saucers. Then, mid-meal, Fermi asks a question that stops the table. Where is everybody? The others understood immediately. Fermi was talking about mathematics. The Milky Way contains somewhere between 200 billion and 400 billion stars and is roughly 13.6 billion years old. A technological civilization expanding at just 1% of the speed of light, far below anything exotic, could cross the entire galaxy in 10 to 100 million years. That sounds like a long time until you compare it to the age of the galaxy. 100 million years is less than 1% of the Milky Way's lifespan. Even with conservative assumptions about how often life arises and how long civilizations last, the galaxy should be crawling with evidence of intelligent activity. Spacecraft, signals, engineering visible across interstellar distances. There should be something. There was nothing. Michael Hart formalized the argument in a 1975 paper. If interstellar travel is possible even at low speeds and civilizations arise with any regularity, the galaxy should already be colonized. The fact that it is not requires an explanation. Every proposed answer still carries Fermi's name, even though he never wrote the argument down. April 8, 1960. A 29-year-old astronomer named Frank Drake pointed an 85-foot radio telescope at Green Bank, West Virginia, toward two nearby stars, Tau Ceti and Epsilon Eridani. He tuned to 1,420 megahertz, the emission frequency of neutral hydrogen, the most abundant element in the universe. Cocconi and Morrison had proposed this frequency in a 1959 paper in Nature as the logical channel for interstellar communication. Any technological civilization would know about the hydrogen line. Drake called it Project Ozma. Over roughly 150 hours, he listened. At one point, a strong pulsing signal came through. The team froze. It turned out to be a high-altitude aircraft. The rest was silence. In November of 1961, Drake convened a conference at Green Bank and introduced what became known as the Drake equation, a framework for organizing ignorance. You multiply the rate of star formation by the fraction of stars with planets, by the fraction where life develops, by the fraction where intelligence arises, by the fraction that builds detectable technology, by the average lifespan of such civilizations. Drake and his colleagues estimated the fraction of stars with planets at 1 in 5. They were wrong by a factor of 5. Between 2009 and 2018, NASA's Kepler Space Telescope stared at roughly 150,000 stars and confirmed 2,783 exoplanets. The statistical analysis that followed was decisive. Virtually every star in the Milky Way has at least one planet. The fraction went to effectively 1.0. Every star. Further analysis estimated 40 billion Earth-sized planets orbiting in habitable zones in our galaxy alone. This was supposed to be good news. More planets means more chances for life. Instead, it made the silence catastrophically worse. With 40 billion potential homes, why is nobody there? 1967. Jocelyn Bell Burnell, a graduate student at Cambridge, noticed a signal, a rapid, precise pulse repeating every 1.337 seconds. Nothing natural was known to pulse with that kind of regularity. The research team labeled the source LGM1, Little Green Men. They were half joking, but only half. Then a second pulsing source appeared in a different part of the sky. Then a third. The explanation turned out to be rotating neutron stars, pulsars. The signals were natural. The episode demonstrated that the universe produces phenomena that mimic intelligence with uncomfortable precision. A perfectly timed pulse, repeating without variation, looks designed. It was not. That lesson would become relevant again and again across the following decades. On August 15, 1977, the opposite happened. Jerry Eman, a volunteer astronomer working with Ohio State University's Big Ear radio telescope, was reviewing data printouts the following day. One sequence jumped off the page. At exactly 1,420.726 megahertz, the hydrogen line, a signal appeared roughly 30 times louder than the background noise of space, with a peak intensity exceeding 250 Janskis. It lasted 72 seconds, exactly how long a celestial source would remain in Big Ear's beam as Earth turned. Eman circled the character sequence and wrote a single word in red ink in the margin. Wow. The signal never repeated. Eman and others pointed Big Ear at the same patch of sky hundreds of times over the following years. Nothing. The signal came from the direction of Sagittarius, from a region with no remarkable star or object. For the next 40 years, the WOW signal remained the single strongest candidate for an extraterrestrial transmission in the history of SETI. The Big Ear radio telescope operated from 1963 until it was demolished between 1997 and 1998. The land in Delaware, Ohio was sold to a developer who built a golf course. The instrument that captured humanity's most compelling candidate for an alien signal was torn down so people could play 18 holes on the ground where it stood. In 2017, astronomer Antonio Paris proposed that two comets, designated 266P Christensen and P/2008Y2, had been in the general area of Big Ear's beam on the night of August 15, 1977. Hydrogen clouds surrounding comets can emit at 1,420 megahertz. Several outlets reported the mystery solved. The explanation was comfortable, except the comets were not actually in the correct feed horn position that night. More fundamentally, the emission power a hydrogen cloud around a small comet can produce is many orders of magnitude weaker than 250 Janskis. Proposing a comet caused the WOW signal is like proposing a candle caused a forest fire visible from orbit. In 2025, a team went back to the original physical printouts from Big Ear's 1977 observation run. 75,000 pages of dot matrix output, sitting in archives for nearly half a century. Using optical character recognition to digitize the full archive, they confirmed the signal's flux density exceeded 250 Janskis. The comet hypothesis collapsed completely. The new best explanation is stranger. Researchers now propose the WOW signal was a rare superradiance event, possibly a hydrogen maser flare triggered by a magnetar. Under specific conditions, a cloud of cold hydrogen gas can be stimulated by a magnetar's intense magnetic field to emit a sudden, intense burst of radiation at exactly 1,420 megahertz. Powerful, brief, non-repeating. The frequency, intensity, duration, and singular appearance all fit. The cosmos generated a signal that perfectly mimicked what we expected from an alien civilization at exactly the frequency we were listening on, using nothing but raw physics. The pattern that followed would repeat throughout the history of the search. Every time scientists thought they had found evidence of technology, the universe offered a natural explanation nobody had anticipated. Every measurable variable in the Drake equation has moved in the optimistic direction since 1961. More stars have planets. More planets sit in habitable zones. Life on Earth started almost as soon as conditions allowed. The last universal common ancestor existed approximately 4.2 billion years ago, only 300 to 400 million years after Earth formed, when much of that window was still geologically hostile. Life did not wait for ideal conditions. It appeared almost as soon as conditions permitted. If abiogenesis is that easy, then life should be common throughout the galaxy. And yet, across 65 years of searching, the answer is still zero. The filter must sit somewhere in the variables we cannot yet measure. In 2024, Stern and Guerrier published a paper targeting one of those variables, the fraction of planets with life that go on to develop intelligence. Drake's original estimate treated this as close to 100%. Stern and Guerrier estimated it at between 0.003 and 0.2%. Their reasoning was geological. Intelligence at a technological scale requires at minimum 500 million years of continuous plate tectonics and a specific ratio of continent to ocean that allows complex ecosystems to develop on land. Of a jar containing 100,000 marbles, under their lower estimate, 3 would represent planets where life develops intelligence. The difference from Drake's near-total assumption is staggering. But the rare Earth argument itself has been complicated by new models. Simulations conducted between 2015 and 2024 showed the relationship may be backwards. Biological activity on the surface may have weakened Earth's crust enough to allow subduction to begin. Life may not need tectonics. Tectonics may need life. When NASA's New Horizons flew past Pluto in 2015, it found unexpected geological activity on a world receiving roughly 1,000th the solar energy Earth gets. Nobody predicted active geology there. The narrow window rare Earth proposed keeps getting wider. In 1996, economist Robin Hanson reframed the Fermi Paradox in terms a betting market would understand. Between dead rock and a galaxy-spanning civilization, there is a long chain of steps. If the galaxy should be full of civilizations, but is not, at least one step must have a near-zero pass rate. A bottleneck so severe that almost nobody gets through. Hansen called it the Great Filter. The critical question is not whether the filter exists. The silence answers that. The critical question is where it sits. If the Great Filter is behind us, in the origin of life or the jump to complex multicellular organisms, then we are rare but safe. The hard part is over. If it is ahead of us, then every civilization that reaches our level of technology eventually hits something it cannot survive. Under that scenario, the silence is a graveyard. For 2 decades after Hansen's paper, the debate stayed roughly balanced. Then in 2024 and 2026, 2 papers landed that shifted the weight sharply toward the worst case. Michael Garrett, an astrophysicist, published in 2024 arguing that artificial intelligence is the Great Filter. His logic was a timeline. Earth's first radio transmission occurred in 1895. 127 years later, generative AI systems began operating at levels that surprised even their creators. Any technological civilization follows a similar trajectory because the underlying pressures, economic competition, military advantage, the logic of tool improvement, are universal. Garrett's estimate for the window between developing AI and being fundamentally altered or destroyed by it is roughly 200 years. Apply that to the Milky Way. The galaxy is 13.6 billion years old. A civilization's detectable phase lasts 200 years. That is like trying to photograph a specific lightning bolt during a storm lasting 4 million years. Even if millions of civilizations have arisen, the probability that any 2 overlap in their 200-year windows is vanishingly small. Earth is already getting quieter. Fiber optics carry data through glass. Digital signals are compressed and encrypted, making them indistinguishable from noise to a distant receiver. Military radar is shifting to focused phased arrays. Earth in 1970 was a bonfire visible for miles. Earth in 2026 is a flashlight pointed at the floor. In February of 2026, a second filter was proposed, one that requires no machines at all. Darren Dogan proposed that the filter is demographic. Any species intelligent enough to decouple reproduction from survival will inevitably experience falling birth rates as a direct consequence of prosperity and choice. His model treats this not as a crisis, but as a thermodynamic inevitability. South Korea's total fertility rate in 2024 was 0.72, roughly 1/3 of the 2.1 needed for replacement. Japan stands at 1.2, Italy at 1.24. China dropped below replacement in 2022. The United States fell below replacement in 2021. These are not projections. These are census numbers. Every government that has tried to reverse the trend has failed. Pronatalist policies in Scandinavia, Japan, Singapore, and Hungary produced temporary bumps before the decline resumed. France, with the most generous family support system in Europe, still fell below replacement. Dogan's projection maps current global trends forward. Human population peaks around 2080 at roughly 10 billion, then begins an accelerating decline. By the year 2500, his model estimates fewer than 100 million humans. By 3000, functional extinction. In the Petri dish, bacteria run out of food. In Dogen's model, the food is still there. The civilization simply stops eating. 2 filters, then Garrett's 200-year AI window and Dogen's 500 to 1,000-year depopulation curve. They are not mutually exclusive. A civilization could face both simultaneously. Both were published within 2 years of each other, based on trends already visible in human data. But both filters assume civilizations destroy themselves or fade. There is another possibility. What if they just go quiet? Earth is getting quieter every year. Fiber optics, compressed digital signals, phased array radar, all of it shrinks the electromagnetic footprint. Seth Shostak at the SETI Institute has been making this argument for years. Advanced civilizations are not louder than primitive ones. They are quieter. A civilization 1,000 years ahead of us might communicate entirely through tight beam lasers or quantum encrypted channels. Their transmissions would be invisible to us because efficiency naturally selects for directed, low-waste transmission. Think of it like mail delivery. A medieval town crier shouts announcements in the square. A modern postal system delivers letters to specific addresses. The information flow increased by orders of magnitude, but the noise dropped to nothing. The entire logic of SETI depends on catching civilizations during a narrow window, when they are advanced enough to broadcast, but not yet efficient enough to stop leaking. That window might be 100 years, maybe 200. On a cosmic timeline of 13.6 billion years, that is a camera shutter click. In 2024, a project called Hephaistos made international headlines. The team scanned approximately 5 million stars within roughly 1,000 light-years, looking for Dyson spheres, megastructures built around stars to capture their total energy output, which would radiate back as excess infrared heat. 7 M-dwarf stars showed anomalous mid-infrared excess that could not be easily explained by known astrophysical processes. News outlets ran headlines about possible alien megastructures. For a brief window, the scientific community allowed itself to consider the possibility that someone, somewhere, had built something around a star. The follow-up analysis came in 2025. Independent teams found that the anomalous infrared excess was real. It just was not coming from the stars. It was coming from objects billions of light-years further away. Dust-obscured background galaxies and active galactic nuclei whose infrared emissions happened to sit along the same line of sight. Once higher resolution data was applied, the megastructure signatures disappeared. The universe had done it again. It perfectly mimicked the signature of advanced technology, using nothing but random cosmic geometry and hot dust. The pattern is consistent. In 1967, pulsars mimicked regular artificial transmissions. In 1977, the WOW signal matched every criterion for an alien broadcast. In 2020, BLC-1 looked exactly like a signal from Proxima Centauri. In 2024, 7 stars looked exactly like partial Dyson spheres. Every time we think we have found something, nature offers a natural explanation nobody predicted beforehand. A 5 million star Dyson sphere search, the largest ever conducted, reduced to zero by dust and geometry. In 2008, the Chinese science fiction writer Liu Cixin published the second novel in his 3-body trilogy, called The Dark Forest. It proposed an answer to the Fermi Paradox that was elegant and deeply disturbing. The universe is full of civilizations. They are all silent because revealing your location is the same as committing suicide. The logic builds from 2 axioms. First, survival is the primary need of every civilization. Second, civilizations continuously grow and expand. But the total matter and energy in the universe is finite. Any civilization that encounters another faces a choice: cooperate or destroy. But cooperation requires trust, and trust requires communication, and communication reveals your position. You cannot verify another civilization's intentions. They might be peaceful today and hostile in 1,000 years. The only way to guarantee safety is to strike first. And because every civilization that has survived long enough to exist knows this, the rational strategy is to stand perfectly still and shoot at any noise. The hypothesis has one property that makes it impossible to fully dismiss. It is consistent with the data. The silence is exactly what a dark forest universe would look like. In 1999, a Russian astronomer named Alexander Zaitsev used the Yevpatoria planetary radar facility in Crimea to transmit a high-powered targeted message towards several nearby star systems. He called it Cosmic Call. He did not consult the SETI community. He did not seek approval from any government. He did not need to, because there is no binding international protocol governing deliberate transmissions into space. None. The reaction in the scientific community was immediate and bitter. David Brin called it reckless and potentially catastrophic, arguing it was the equivalent of lighting a bonfire in a forest full of predators. He resigned from SETI-affiliated committees in protest. Seth Shostak at the SETI Institute took the opposite view. Earth's military radar has been leaking detectable signals into space for decades. Anyone within 200 light-years with the technology to threaten us already knows we are here. Hiding is pointless because we never were hidden. The debate has never been resolved. The Métis controversy proved that any individual with the right equipment can speak for the entire species, and there is no institutional structure to prevent it. On December 1st, 2020, the 900-ton receiver platform of the Arecibo Observatory broke free from its cables and crashed through the 305-meter radio dish below. Engineers had been warning about cable degradation for months. The National Science Foundation chose not to rebuild. Big Ear in Ohio, the instrument that captured the WOW signal, was demolished between 1997 and 1998 for a golf course. The Allen Telescope Array, a field of 42 dishes in Northern California designed specifically for SETI, went into hibernation in 2011 because the SETI Institute could not afford $1.5 million a year to keep it running. For context, a single AF-35 fighter jet costs $80 million. NASA's first dedicated SETI program was killed in 1993 after 1 year of operation at $12 million annually, roughly the cost of 600 feet of interstate highway. Since 1993, every major SETI effort has been privately funded. The search for the answer to whether we are alone depends entirely on individual donors and the occasional billionaire. In 2015, Yuri Milner stood on a stage in London alongside Stephen Hawking and announced, "Breakthrough Listen." $100 million over 10 years. The largest single injection of funding in SETI history. The program gained access to Green Bank, Parkes, Meerkat, and the automated Planet Finder at Lick Observatory. By 2024, the project had scanned approximately 1 million nearby stars and accumulated more than 2 petabytes of data. Its sensitivity was sufficient to detect a transmitter equivalent to a small nuclear power plant from nearby star systems. If anyone within a few hundred light-years was making any deliberate effort to be heard, these instruments would have caught it. Nothing did. Then, in 2020, the Parkes telescope detected a narrow-band signal at 982 megahertz, appearing to come from the direction of Proxima Centauri, the nearest star to our own, 4.24 light-years away, already known to host at least one planet in the habitable zone. The signal was designated BLC-1, Breakthrough, Listen. Candidate 1, the first signal the project had ever considered promising enough for a formal candidate designation. BLC-1 drifted in frequency in a way consistent with a transmitter on a rotating planet. It appeared only when the telescope was pointed at Proxima Centauri. When the dish moved, the signal vanished. When it swung back, the signal returned. The team worked in near secrecy for months, applying every filter in their pipeline. BLC-1 survived them all. In 2021, the team published a thorough analysis showing BLC-1 was almost certainly human-generated radio frequency interference, intermodulation products created by electronics operating near the park's telescope itself. The drift rate was within the range producible by local sources. The on-off pattern was explained by the telescope's side lobes picking up local signals at certain pointing angles. BLC-1 was electromagnetic noise from approximately 0 light-years away. If local interference can mimic every characteristic of an extraterrestrial transmission, the bar for a confirmed detection is effectively unreachable with a single instrument. Any credible claim would require simultaneous confirmation from multiple independent telescopes on different continents, ruling out every terrestrial source independently. In March of 2023, an instrument called COSMIC came online at the Very Large Array in New Mexico. It piggybacks on normal astronomical observations. Whatever the VLA is pointed at on any given night, COSMIC processes the same data in parallel, searching for narrowband signals. It gets telescope time for free. In its first 11 months, COSMIC observed more than 950,000 unique fields covering 267,510 individual stars. 0 technosignatures. In 2024, the Murchison Wide Field Array surveyed 2,800 entire galaxies for technosignatures. Nothing. In October of 2024, the Allen Telescope Array conducted the longest continuous SETI observation ever aimed at a single target. 28 hours pointed at TRAPPIST-1, a red dwarf 39 light-years away hosting 7 rocky planets, 3 in the habitable zone. 2,264 candidate signals were generated. Every one was traced to terrestrial origin. In July of 2025, the third confirmed interstellar object, 3I/Atlas, entered the solar system. The ATA pointed at it within days. Over 7¼ hours, the array recorded 74 million narrowband hits. Automated filters reduced that to 211 candidates. Final result? 0. The instruments are orders of magnitude more powerful than anything Frank Drake could have imagined. The number has not changed. It was 0 in 1960. It is 0 now. For decades, SETI researchers deflected the silence with what is sometimes called the hot tub argument. Jill Tarter, who spent 35 years directing SETI searches, put it this way. Imagine you want to know if there are fish in the ocean. You scoop up a single hot tub of water, find nothing, and conclude the ocean is empty. All of SETI's searching amounts to a hot tub from a cosmic ocean. Less than 1% of the sky has been searched at the frequencies and sensitivities that matter. That argument has stopped working. The data is now cumulative. 12 billion candidates from SETI at home, 2 petabytes from Breakthrough Listen, 950,000 fields from COSMIC, 2,800 galaxies from the MWA, 74 million narrowband hits from an interstellar object. Different instruments, different frequencies, different analysis pipelines, different parts of the sky. Always the same number. Statistical models built on 6 decades of null results estimate fewer than 1 to 5 detectable technosignatures per century across the entire Milky Way. That is not a hot tub anymore. That is a measurement. 0 is not nothing. 0 is a finding. In 2024, researchers found free molecular oxygen being produced at the bottom of the Pacific Ocean by polymetallic nodules, lumps of metal ore sitting in total darkness where no photosynthesis is possible. The nodules generate small electrical voltages through natural electrochemical reactions, sufficient to split seawater into hydrogen and oxygen. No biology required. This cracked one of the most foundational assumptions in astrobiology. Atmospheric oxygen had been treated as the gold standard biosignature, a chemical indicator of life because nothing non-biological was known to sustain it. If oxygen can be produced without life on Earth, it can be produced without life on a rocky planet 40 light-years away. Oxygen alone is no longer sufficient evidence. You would need an entire web of atmospheric signatures pointing toward biology rather than geology or chemistry. In 2023, the James Webb Space Telescope analyzed the atmosphere of K2-18b, a sub-Neptune 8.5 times Earth's mass orbiting a red dwarf 124 light-years away, and detected what appeared to be dimethyl sulfide, a molecule produced on Earth almost exclusively by marine phytoplankton. The headlines were immediate and global. Then independent teams examined the data more carefully. The signal sat within the noise floor of the observation. Follow-up analyses using different atmospheric modeling approaches could not reproduce it consistently. By early 2026, the scientific consensus had shifted. The signal was probably an artifact of data reduction, a ghost in the numbers rather than a molecule in the sky. As of this investigation, no exoplanet has a confirmed atmospheric biosignature. Not K2-18b, not any of the 7 worlds orbiting TRAPPIST-1, not the 2,783 worlds cataloged by Kepler. The tools are not broken, but the confidence we placed in them was premature. Robin Hansen extended his great filter concept into a mathematical model he called Grabby aliens. The premise is straightforward. If even a small fraction of technological civilizations decide to expand outward at even a modest fraction of light speed, they should be visibly reshaping the galaxy by now. A single civilization expanding at 1% of light speed would fill the entire Milky Way in 10 to 100 million years. The galaxy is 13.6 billion years old. There has been enough time for this to happen thousands of times over. Hansen's model predicts a galaxy at least partially engineered. Visible expansion boundaries stretching across hundreds of light years. Unmistakable infrared waste heat from stellar energy harvesting. Carved out spheres of influence detectable like the large-scale structure of the cosmos. The actual galaxy does not look like that at all. No megastructures anywhere, no expansion fronts, no reshaping of any kind at any scale. Hansen's calculations show that for multiple civilizations to coexist in the same galaxy without encountering each other, they would need average lifespans exceeding 280,000 years. Garrett's model gives civilizations roughly 200 years after developing AI. Duggan's model gives them 500 to 1,000 years before demographic collapse. Neither comes anywhere near 280,000. The conclusion is stark. Civilizations do not expand because they do not last long enough to begin. In the mountains of Guizhou province in southwestern China, a natural limestone depression holds the largest single-dish radio telescope ever constructed. FAST, the 500-meter aperture spherical telescope, replaced Arecibo as the world's most sensitive radio ear after its collapse in 2020. Since July of 2025, FAST has been working through the 100 signals that survived all automated filtering from SETI at HOME's 21 years of operation. The anomalies that volunteer computers worldwide could not classify as interference or noise. FAST is re-observing each one, pointing its dish at the same celestial coordinates, listening for any signal that repeats. As of early 2026, FAST has reported nothing from any of the re-observed candidates. Meanwhile, machine learning algorithms developed for breakthrough listen process radio telescope data 600 times faster than conventional methods. The Allen Telescope Array is being upgraded to cover frequencies up to 18 GHz. Commensal systems are being installed on radio telescopes across 4 continents. The search has never been faster, broader, or more sensitive. The result has not changed. Here is what the evidence has established. 65 years of organized searching, from Project Ozma to Cosmic. 12 billion candidates from SETI at home. 74 million narrowband hits from an interstellar object. Every candidate resolved to noise, interference, or an unpredicted natural phenomenon. Every promising detection either debunked or unconfirmed. Every measurable variable in the Drake equation moved in the optimistic direction since 1961. Each revision should have made the silence less probable. Instead, each one made it more statistically significant, because the expected number kept climbing while the observed number stayed at 0. The filters stack. Intelligence may require a specific geological history that fewer than 0.2% of life-bearing planets develop. Civilizations that reach technology face artificial intelligence within 2 centuries of their first radio transmission. Those that survive AI face demographic collapse within 500 to 1,000 years as fertility rates drop below replacement. The detection window during which any civilization produces electromagnetic signals strong enough to cross interstellar distances may be as narrow as 100 years. 100 years of detectability against 13.6 billion years of cosmic history. That ratio is a single water droplet falling into Lake Michigan. The instruments keep getting destroyed. Arecibo collapsed and was not rebuilt. Big Ear was demolished for a golf course. The Allen Telescope Array was mothballed for lack of $1.5 million a year. Congress killed NASA's SETI program twice. The biosignatures we trusted turned out to be less reliable than believed. In 1999, one man used a radar dish in Crimea to broadcast humanity's location to the galaxy without asking anyone. No binding protocol prevented it. No binding protocol prevents it today. The investigation does not conclude with a resolution. It concludes with a measurement. The universe has had 13.6 billion years and hundreds of billions of stars. On at least one planet, life started almost immediately and eventually produced a species that built radio telescopes and asked, "Where is everybody?" The silence is the information. Something about the journey from microbe to interstellar civilization is so difficult, so improbable, or so brief that in 13.6 billion years, it has either never been completed or never lasted long enough to leave a trace. That is not philosophy. That is what the data says. Earth has been broadcasting for roughly 100 years. The radiosphere expanding outward from this planet currently contains about 15,000 stars, roughly 0.00004% of the Milky Way. A civilization with a Green Bank-class telescope aimed at our sun during the right century could detect us. But Earth is already getting quieter each year. The window, whatever its true length, is finite. If Garrett's model is right, we are 127 years into a 200-year window. If Dogen is right, we have 500 to 1,000 years remaining. Take the generous number. 1,000 years of detectability in a galaxy 13.6 billion years old. For another civilization to notice us, it would need to exist at the same time, within range, with instruments pointed our way during our window. We would need the same from them. 2 fireflies blinking in a forest the size of a continent. Each flash lasts a fraction of a second. Each firefly is real, They miss each other by 100,000 years and never know the other existed. In July 2025, the Allen Telescope Array tracked the third confirmed interstellar object through our solar system. 7.25 hours of listening. 74 million narrowband signals. 211 candidates after filtering. Everyone came from Earth, somewhere around another star, right now. An instrument may have scanned our solar system and found the same thing. The silence does not prove we are alone. It is consistent with a universe where the windows are small, the distances are immense, and 13.6 billion years is not enough time for brief flashes of technology to overlap across a galaxy 100,000 light-years wide. Civilizations arise, broadcast for a geological instant, and go quiet. The galaxy could be full of ruins. It could contain thousands of civilizations that existed millions of years apart and never coincided. Any of those possibilities produces the same observable result. 0. FAST is still listening in Guizhou. The James Webb Space Telescope is still analyzing exoplanet atmospheres. Breakthrough Listen is processing data 600 times faster than 5 years ago. The question Enrico Fermi asked over lunch in 1950 has not been answered. The instruments are more powerful than they have ever been. And the window, whatever its true length, is still open. Here is the rewritten and translated English language script, compacted to approximately 50% of the original volume, with full content preserved.